balloon. Uh, I'm going to create a balloon and heat it up a little bit top one. Okay? If time allows it, I'll do a second experiment. Okay. First, I'm going to blow up this balloon. And then I'm going to tie it. Okay. As you can see, it's this size. Now I'm going to use a string. First, I'm going to place it on here. Okay. Then I'm going to go all around and then right here. Touch right here. I shall show you. Just a minute. And there. Okay. As you can see, it's kind of like this. Then I'm going to use a Sharpie to mark where it is. I'm going to do a mark straight across so that I know where to start and stop. Okay? Marked. Now I'm going to use my tongs here. Oops, sorry. I'm going to use my tongs to put it over balloon. Pause. As you can see, the water is boiling. This.
Speak up.
Here, and you can see that. I'll just show you. Using my math skills, I've written some calculations. First, PV equals to nRT, and V1 by V2 equals to T1 by T2. P is constant, so yeah. And then T1, I found it out to be 77 degrees Fahrenheit, as you can see here, which is 298 degrees Kelvin. T2 is 90 degrees. I estimated about 90, which is 363. The volume increases by about 22% maximum. Okay? Using that ratio of volume, I found how much the radius increases. As you can see, the radius only increases 6%, 6.8. So,
Show your face.
yeah. And so now I'm gonna get my string. Okay, other than magic, I found my string and everything. Okay, then I'm gonna measure the diameter. Okay, first I place it here, and I go all around and find out where's my other marking. So, as you can see, it moved about a length. It moved about this much. So, I'm just going to mark that. So, it didn't move that much. It moved about a thumb's width and a little bit more. Maybe 2 fingers width. Yeah. And so, the volume only increased. You can say that the volume increased 6%, but it's more like this volume just increased a little bit, and it's not that much, you know. It was for originally 6%, right? But then this actually probably only went 5%, and with little errors in the calculations and everything. Chemistry has errors. And so yeah, the string right here, right, you can see it's a little difference, and it's not that much. It doesn't even compare to the width of this. It doesn't even compare to this width. The cap. It's probably like 2 inches. Yeah. I'm just gonna turn off this, and then I'm gonna move the string right here so that it's easier to see. And I'm gonna magically find a ruler. Voila! And then, so yeah, I'm gonna measure from here, from this end, where our first name I'm marking, which is 12 inches already, so I have to flip it over. Oh, that's not it. 12 inches already, and then right there, flip. There to about 12 inches, and then it's like 9.5 is the first marking, and 10.1, you know, 10.3 is the second marking. Yes. I'm gonna just put this up. So that was 12 plus 9.5, which is equal to 21.5 inches. Inches. While the other one was 12 plus 10.1, which is 22. Actually, no. 10.3. Yeah, 22.3. Okay. 12.5. I mean, 22.3 divided by 22.5 equals to, I need a calculator for this. 5. Okay. Then magically appeared a calculator. So 22.3 divided by 1, wait no, delete. 21.5, that's, go to, delete. Yeah, that's 1.037. That is 3.7% diff. So that's not that much. And yeah, maybe because we did not put it for long enough, we got 3.7, but it was expected. For me, I estimated it to be around 4.5% difference, but since I did the experiment and everything, it's 3.7. Now I'm gonna do a second experiment. I filled this up with cold water from the sink, and so then I'm gonna put a balloon over it. Balloon over it, yeah. As you can see, there's no air inside, and then yeah. Then I'm gonna put it in this boiling water. Okay, same boiling water that I used, but boiling water nevertheless. And then I assume that the balloon will blow up and probably get up to the size of the last one after some time has passed, but yeah. This balloon is not that blown up yet. So this one will still be applicable because the volume is constant. The amount, that means the amount of water is constant.
Pressure is constant.
And the pressure is also constant.
Volume is not constant.
The volume in right here is constant, but the balloon's volume increases. Heat is being supplied to it, and this is not, the water is not hot enough to boil the water inside the bottle. The water inside the bottle is used solely for the purpose of not melting this plastic bottle. And as you can see, it has already come up to this extent from the little small balloon. This was 22%. I expected that. And this balloon, it was like this, and then now, look at this. Like this, from here to there. And I don't think that this will go up anymore, but I think we should just wait a few minutes. This balloon will not go up anymore. So this one is about, what, half a liter maybe? What's the serving size on this? Yeah, I think that this is around half a liter, no? Oh, yeah, right here. It says 500 ml. So then this is about what? This inside, the air inside the balloon is about, I think, 17% or 16%. It's not that much. And according to theory, it should be 20% or 22%. And I think, if you think about it, I would probably change my guess to about 15% or 14% because it's not heated up that much. And this balloon won't expand anymore. Even when I translated this is the air has escaped. So yeah. I'll just turn this off and I'm putting this under cold water. A few seconds ago I stopped the camera for some odd reason. My cell phone was going off. You know, I put it under cold water. I felt some water go down. So I think the water has heated up and then went into the balloon, but I'm not sure. It might have been like when I did this, the water went into the balloon and did that. Yeah. And this is the final product.